Alright, so in the last episode, we got our input panel working. So now we can type something in on the screen when we are prompted for input and have that get accepted into the visual novel. Although it's not showing up on screen, what we input is not being thrown into the text that comes after, that is. So we're not injecting it anywhere, but we are accepting the input and we are storing it so that way we can access it later and store it into the values that can then be injected into the dialogue. So for right now, we got the system up where it can be called and hidden. So now we're going to integrate that system into the dialog files. And we'll do a small little test so that way we can just inject something straight from our input panel into the dialog. So we'll do a test in that. But the real system for throwing in whatever we throw into the system here, whatever we type in and accept, that's going to come later, once we actually get into the save file and we have a place to save the input that we give the visual novel. For now, we're just working on the system, and now let's go ahead and integrate it into the dialog files. So for us to do that, we're going to need some way to know when to call this thing to show up. So in our dialog files, we know that we can call commands, and commands can cause things to happen in the scene, and we could even wait for those commands to complete. So theoretically, what we could do is we could have a first line here saying, narrator is asking, what is your name? And then maybe we could have input as a command and just wait for that to complete, and then we move on to the next line, which would be narrator, and nice to meet you, followed by the main character tag, so that way it can be injected. Now, that could work, but to be honest with you, I don't like it, so I'm not going to do it that way. Instead, what I want is to have something separate from the commands, and that's just a logical line, what I was talking about in the last video. So it's just another type of line we can run here. So instead of doing a speaker and dialogue, we'll do the name of what we want to call, which is going to be input. This is going to be the logical command. And then inside of quotes, so it's kind of like speaker and dialogue, then we'll have the title of what we want to show up on screen. So we could have type your name in here. And then we will have the input panel show up because it will analyze this line, figure out that this is actually a logical line because it detects a keyword for input. And so once we have that keyword, it'll know, okay, this is the title for the input panel we want to show up, and we shall wait until this logic finishes running, and then we'll move on to the next line. So it's kind of like a command, but a little smarter, and it just gives us more opportunity for growth and for customization and adding all kinds of different features in here. So let's go ahead and get started on this logical system, so that way we can have the groundwork for all of our other kinds of lines, including choices and randomized dialogue and all that good stuff. So to manage our logical lines, we're going to create a new manager. So if we come into scripts and core, then we have the logical lines folder here, and I actually am going to move input panel out of there. I don't know why I stuck that in there last video. Not the best place for it. So I'm going to make a new folder in here just to store that in. And I'm going to make this panel, or this folder, the feature panels. And so feature panels will have an input panel and eventually the choice panel. And so that means logical lines is empty, and this is strictly where all of our logical lines, the management system, and the different kinds, they'll go in here. So we need a manager, something that's going to be communicated with by the conversation manager, since that's what handles the dialogue lines. It's going to pass it into the logical line manager, and it's going to tell us what needs to happen to it, if anything. So this class is going to be the logical line manager. So I've placed this in a new namespace for logical lines under the dialog namespace. And we'll go ahead and remove start and update, because like the tag manager, this is going to be something that's spawned specifically for the conversation manager, since it's the only one that's going to need to access this. So if we just jump to our conversation manager real quick, let's go ahead and add it in here. We'll make this private logical lines. I'll need to include that interface. So logical lines dot logical line manager. Actually, I'm just going to go ahead and say using dialog. logical lines. We're going to go ahead and use that, and then specify a logical line manager, logical line manager. Okay, and so when we start, we have our tag manager that's created here. So let's create a new logical line manager. Perfect. So what's this thing going to do? This thing is going to analyze the dialog line that's parsed, and then by looking at the line, it's going to determine whether any sort of special logic needs to run on it. In order to do that, it needs to have something to compare each line to, and that would be the different logical line types. Now, the best way I can think of adding something that's going to be unique for, or rather, it's the same, that's complete opposite of what I just said, the same for each one of these different logical line types is to unify them with an interface. So as we create the different scripts that will represent the different logical lines, they will all be a part of this interface using the same functions. So let's go ahead and create that right now. We'll make this an iLogical line. So for this interface, let's go ahead and remove start and update as well as mono behavior and change class to interface. So our logical line manager is going to store a cache of these logical line types, and it can then check all of these, every one that will be in our project, similar to how the command manager identifies all the different command databases. We just create a new one as we want to create different kinds of commands for different objects like audio, characters, graphic panels, that sort of thing. Same deal here. We'll be making a different type of logical line for each purpose that we want to, for each feature that we want to add into our dialog files. As for how this is going to run, in our logical line manager, let's make the function that's going to determine what sort of logic needs to run. This is going to be a public Boolean function. We're going to return true or false whether the line is logical or not. So let's go ahead and name this try get logic. And what we're going to be examining is the parsed line from our dialog file, and that is just the dialog line type, and we'll call it line. And if we find any kind of logic to run, this is something that our conversation manager is going to need to wait until it finishes. So we can do that in a coroutine. So if there's any kind of logic, the conversation manager is going to freeze where it is and wait for that to complete, and then it'll move on to the rest of the lines. So we'll make something that can be assigned, we'll cast it out to a coroutine type called logic. So what this function is going to do, let's say if nothing matches, then logic is going to equal null, and we'll just go ahead and return false. So that way there's no logic, and we'll just treat what we have as a regular line, and we'll run the speaker, the dialogue, and the commands if there are any. However, if it matches something, then we're going to find out what kind of coroutine needs to run from it, and that needs to be something that we can retrieve from our interface. So based off of those two requirements, we know we need at least two things in this interface. We need something to determine whether that line matches this particular logical line, and also the coroutine that needs to execute. So let's make those two commands. Let's make a Boolean returning command to see if we have a match. So this will be matches, and we're going to check the dialog line called line. Since this is an interface, we won't populate it with anything, but we'll just end that with a semicolon. And then we also need the coroutine. Now, we're just going to return the IEnumerator because we'll call it straight from the logical line manager. So we'll have our IEnumerator type, and this will be called execute. This is the logic. So for our manager, we need a list of all the lines that can possibly be run and evaluated. We can keep track of this with a private list of that interface type. So iLogical line, called logical lines, and that will just equal a brand new list. So say that we have lines that have been populated in here. What we could do is we could loop through each one of them and see if this line matches the criteria of any of those lines, and then execute whatever logic is attached to it. So we can loop with a simple for loop for var logical line in, God help my spelling, in logical lines, I need to do for each. I always do that. Okay, so for each logical line that's in our list, let's go ahead and see if our logical line dot matches the line that we are evaluating. If it does, then we can go ahead and start the coroutine and make sure that we return true. So we know that we have valid logic, so we're going to return true here. Now, it's given an error because since we're casting something out, we need to make sure that we assign that value for logic before we return the value. So we just need to say that logic equals the return value of this execute command. Now we need something to execute it on. And the logical line manager is not going to be a mono behavior, so let's get rid of that, because it's going to be spawned by our conversation manager simply in memory. So what we need is a reference to something, and we can just run all of this off of our dialog system. So we'll go ahead and say private dialog system is the dialog system.instance. So we'll say logic equals the dialog system.start coroutine, and we're going to start the logical line dot execute. So we'll start whatever logic is assigned to this, and we will be able to yield for the duration of it. So let's go ahead and create our first logical line. Let's make a new folder for the types. And inside of types, let's create the new logical line type inheriting from this interface. So I'm going to start it with LL for logical line, underscore, and just make this, let's say, input. Because this is going to be the line that will bring up the input panel for our player. Let's open that up. And the first thing that we want to do is we want to get rid of start and update. We really don't need that in there. And I'm also going to encapsulate this into my dialog logical lines namespace. But the real important part here is we change from mono behavior to that I logical line interface. And we should get an error immediately because we're not implementing the required members of this interface. So we can just do control dot implement interface, and we have them ready to go. Though they're not doing anything, so we need to actually assign something here. So for our logical line, we know that for input, we're looking for a keyword in our line. Let's take a look at that chapter file again. So here's the logical line. So this is what I'm looking for. If I'm starting with input, then I know that this is a logical line to bring up the input screen. Now, if we just look at this like any other line, then what it looks like is input is the speaker, and the dialogue that input is saying is type your name here. So since this has already been parsed, what I could do is just look and see if the speaker name is input. Or we could capture the raw line before it's parsed and cache that into the dialog line, and then just check if it starts with the keyword. I can see where both of those would be handy. So in essence, we'll already have it parsed for us, so we may as well go ahead and check the speaker name. But what if we don't have any dialogue? Then we may not have a speaker, and we may not have any dialogue, so then we would need something else to evaluate our logical line keywords. So we'll go ahead and make it where we can cache the raw data, but for the input panel, I am just going to look at the speaker name and see if it's input. Let's go to our dialog data containers and go straight to our dialog line object. As we work with this, what we could do is we could cache the raw line that's before we actually start splitting all of this stuff. So for this dialog line, let's go ahead and make a public string for the raw data. And we'll make it where anything can get it, but it can only assign itself. Equal to string.empty, and I'm going to copy that line because I'm going to use that for our other types. So speaker data, I'll go ahead and do the same thing, as well as dialog data. So we'll have the raw data for all of this stuff. We especially want it for our dialogue data because our dialogue is split into different segments. So our raw data will just give us all the segments combined as they were before anything happened. And all we have to do is just say this.raw data equals raw dialogue. And for the speaker data, we can come down to speaker data right before we process the keywords and say raw data equals raw speaker. And as for our dialogue line, we can go ahead and say that raw data equals something. How about we go ahead and just pass in the raw line as a first parameter before the speaker, dialogue, and command, since they're already split up here. So raw data will just equal the raw line. And a quick way to go ahead and edit the parser is, let's just hop back into Unity, and we should get an error because we've changed the parameters. So let's go into the dialogue parser, and this class is the one that creates the dialogue line by passing in the speaker, the dialogue, and the commands. Let's go ahead, since we changed that, and also pass in the raw line so we can cache that into the dialogue line. By doing that, we now have access to the line.raw data, which for any of these lines would be everything that we see. And that can be useful for identifying some different things in the lines if we need to do some debugging or if we need to do some key detection. Okay, so back to this. Our logical line manager is looking through each logical line in its list, and then it's going to see if it matches the line. So let's go to our LL input. So what's happening when we're looking for this? We're looking for that keyword input. So let's get ourselves a keyword variable. I think I'll add this to the interface and give ourselves a string for the keyword and just make this a getter so that way it can be in our interface. And so now that will require our LL input to implement a keyword. So public string keyword will just equal input. So that's the keyword that we're looking for here. And so let's check if, well, we don't have to do if here. We can do just return, and return true if our line dot has a speaker and our line dot speaker data dot name equals the keyword that we're looking for. Just for safety, I'll go ahead and convert that to lower. That's way it's case insensitive. So as long as it matches the keyword, that speaker, which has already been parsed for us, as long as it matches the keyword we're looking for, then we know we have a match, and we'll go ahead and try to execute whatever this code is. And that brings us to throwing this up on screen. So, very first thing we can do is we can grab the input panel. Now, we're not exactly going to have a reference to the input panel in the screen, unless we reached out to maybe the dialogue system and cached it in there, but there's really, I don't see much of a point in doing that. What I'm going to do is I'm going to go ahead and create an instance of our input panel, since I'll really only have one in the scene, and I'll just grab it for our logical line whenever I need it. So I'm going to make a public static input panel and call this the instance. And then I'll just make I really don't need this in awake. I really don't, so I'm just going to do that in start. Because the logical line is not going to be run on awake, so it'll be run on, yeah. Maybe at some point that could happen. Let's just be safe about it. So private void awake, we'll say instance equals this. I'm not going to worry about trying to destroy anything if it exists. There's no reason why this thing is going to be in the do not destroy on load layer. So we'll go ahead and just assign the instance to this. And that means for our logical line for the input, we can go ahead and grab that instance. So we can say input panel, panel equals the input panel dot instance. And now we can say panel dot show, and hang on. We need a title. We need something to show as the title for the input panel. That way we know what to input in the screen. So what we could do is in execute, we could pass in a string value for the title. and then we can just pass in the title into our show command. But then we have an issue because this does not fall in line with the interface's definition for the execute function. Because the interface is not expecting this value, let's go into the logical line interface and just add a string called data and set it to nothing by default. That way we don't have to pass it in if we don't want to. But if we do, then we know we have the title here. So now that we've got the title, let's go ahead and say while our panel.is waiting on user input, yield return null. We're going to wait until that's done. And that's all we need to do. We're just going to wait until that panel closes, and then we've got the input we need, and we'll move on to the next line. Okay, great. Now that'll work as long as we've got some logical lines in this list. So when we create this for the conversation manager, let's go ahead and initialize that list with all of the logical lines that we've defined within our assembly, just like we did for our command manager. So let's make the constructor for when this is created, the logical line manager. So this is what the conversation manager will be calling. And this is just going to return, what are you doing? Visual Studio. I do not like that. Okay. So we'll go So we're just going to call a function called load logical lines. And let's go ahead and generate the method here and just make this something that's going to reach into the assembly that we're using and grab up all of the types that come from this particular interface that we're looking for. So we need to make sure that we're using the right namespace. What we're going to need up top, let's do using, what is it? It's system.reflection, yeah. And we're also going to need some link. So using system.link. All right, now let's go ahead and grab everything. We'll start by grabbing our assembly. That way we can get all the code in it. And then we'll go ahead and get all the types in the assembly so we can evaluate them, and we're only going to get the ones that are a type of the logical lines where they are assignable from the logical line interface, but they are not the interface itself. And then we're just going to turn all of that into an array so we can loop through it and add it to our list. And that's just looping through each type and then creating an instance of it and adding that new instance to the logical line so that way we can get our data from it and get the logic that needs to run. So with this, we have our logical line system set up and we are cool and free to use it as long as we get our conversation manager to recognize it. So the next part of this endeavor is jumping into our conversation manager and telling it to run the logical lines. So we can come right down to the portion where we start running the conversation. When we run the conversation, we're looping through each line within our dialog file and then converting that into a dialog line that we parse to get all the data we need. This is the point where we can evaluate it and see exactly what we're dealing with, and then find out if this is a regular line or if it's a logical line. So first, let's go ahead and take a look within our logical line manager and see if that is the case. Let's check. If logical line manager dot try get logic, and we're going to try to check this line, and we're going to cast out the result to a new coroutine value called logic. We'll just do it just like we defined before. So if that's the case, we'll go ahead and yield return the logic. So we'll wait for it to finish. Otherwise, we'll go ahead and run all of this code. So if it's a logical line, we're going to run that logic. If it's not, then we're going to run the speaker and the dialogue and whatever commands may be there. So let's go ahead and run this dialog file now. Narrator is going to ask, what's your name? Then we're going to run that format here with the keyword of input. So we declare that this is a logical line for input, and we will ask the question, or we'll put on the title, type your name here, we'll wait for us to type, and then we'll go ahead and say, nice to meet you, main character name. So as long as we're running that testing file, let's go ahead and jump in, and what is your name? We click it, okay, so we hit the visual, or the input line, and we can see we have no title. But we do have our input and we have our accept, so we accept it, and now we move on. So the reason we didn't have the title is I actually forgot to pass in that value to the execute command. When we try to get the logic within our logical line manager, looking at the logical line as long as there's a match, we go ahead and get the logic by starting that coroutine and execute it. But I would need to pass in the line.dialogdata.raw data. I need to pass that in, because the raw data is going to be all of the dialogue that comes after the keyword. Now, here's the problem though. Not every single logical line is going to have dialogue data to it. Now, maybe they will. Maybe the whole line will just be parsed as dialogue, and then we can get what we want. But I think instead of splitting it up and just passing in dialogue data which may or may not be there, we can just pass in the line, and we can just grab the data that we need directly from the line instead. So that way, for each logical line, it can determine what it needs from the dialogue line, instead of having it force-fed to it. That just means for our interface, we need to copy that and change our data to the line. And then from our input panel, we'll go ahead and make sure that we have our dialogue line here. And then we'll just say that string title equals line.dialog data raw data. There. And so I'm going to say, what is your name, bruh? Okay, so we run it. What is your name? Then we get the input, what is your name, bruh? And I'll go ahead and put in, actually, I'll go ahead and put in just something random. Constipated warlord. And then we'll go ahead and accept that. And nice to meet you, Avir, because we're not injecting that into the main character tag. Okay, so it looks like that is all working. Let's just pop this up one more time. What is your name? What is your name? So I can click all around. I can hit my spacebar, my enter, all my keys that should be making this go forward. My auto, skip, and none of that is working. So it's not going to do anything until this logical line finishes running. So I need to put in the name there, accept it, and then we can move on. So there we are. We've got our very first logical line integrated into our dialogue system, and we can now input text right in there. So the next video, we're just going to do a quick implementation of how we can create a cache system in the tag manager, assign our input to a cache tag, and then inject that in.